Hello guys and welcome back to the SimpliCode programming channel. This is Vikesh and let's get started with today's topic, which is about the static keyword in Java. Now let's first understand the need of the static keyword and then we'll talk about how Java implements the static keyword. Imagine a scenario. Let's take the example of a class which we have been using in our different tutorials in this particular series, which is about the student class. So if you are building a college management system, you have a student class there, and if you have an entry, a property in the student class which is storing the name of the college, then the name of the college is going to be the same for all of the students of that particular college. It's not going to change. Another example, let's say you are building a employee management system for an organization and you want to maintain the employee numbers. For the first object, the employee number should be 1. For the second object, the employee number should be 2. For the third object, the employee number should be 3, so on and so forth. So when you initialize all the employee objects, the last employee object has the final total employee count. And you can also treat this employee count as, let's say, the employee number as the employee ID. So starting from the first employee to the last employee, the employee number is the employee ID, which is a way to uniquely identify an employee. So we talked about two different cases. In the first case, we had a particular value which was same for all of the objects, which was the student and the college relationship. And then in the second example, which I quoted, where all the employees objects have to share a particular property amongst them. Because if the second object did not know the previous value of the employee number, it will not be able to get to the new number. It needs to know what was the previous value so that it can do +1. So each of the object needs to know the state of the previous object. Two different cases, two different scenarios, one single solution, which is static keyword. So the static keywords are used for those members which belong to the class. Now apply this definition to the examples which I gave you. If I make a member of the student class, let's say the college is the property of the student class, and if I make that property as static, now that static member becomes the property of the class and not the property of the object. It means it belongs to the class. It also means that all of the objects will get the same copy of this static member variable. And that's one of the first usage. And you can make any property or any member of the class as static by just putting the static keyword in front of it. We also call the static member variables as class variables like I just described. So use it for the cases where the value across the different objects doesn't change. You can make those class variables and those variables as class variables or static variables. Similarly, also try to identify the cases where a particular value has to be shared in terms of knowing the previous state. In those cases as well, you can use a particular member in that particular class and make that static. For example, in this case, we have a bicycle class and we have a static variable which says number of bicycles. So every time you initialize the bicycle object, this number will be shared. And you can see, this is here, it is incrementing the number of bicycles. So every time you create the object, the ID becomes +1 to the previous count of the number of bicycles. Exactly same example as I gave you for the employee number. So every time you create an object, you do a +1 to the previous value. Next object will take the previous value +1 and so on and so forth. So you can use the static keyword in front of a property of the class and make it a class level variable, which will be tied to the class and not tied to the objects. You can also make the methods as static as well. And the same kind of rule will apply on the methods as well, that the methods will belong to the class instead of belonging to the objects. Let's say you have again a common functionality which you want to share amongst objects. Just make that common functionality as a static method, and that would be shared amongst the objects. For example, you want to get the total number of bicycles for the previous example, which I just shared in this particular doc here. So you can just create that method as static, and any object which will call this method will get the latest count of the number of bicycles. You can also make these static variables as constants by putting the final modifier in front of it. So if a variable in a particular class is static and final both, then technically it becomes a constant. So these are some of the interesting use cases and constraints of the static methods and static variables. There's also a thing called static block, which is just a code block which you can write inside your class. And we will have a look at that example as well. So let's shift to the IDE and let's have a look at how we can use this static keyword. So I have used the same class which I have been using in other examples, which is student.java. And you can see I have this same class. You would have seen these properties earlier as well. And the code below is exactly the same, just setters and getters and constructors. And it has an additional property which is college. And the college name XYZ is the same for all the students. So I have just hard coded it. But you see, what is happening here is that every time you create a student object, this variable gets initialized. Even though the variable for all the objects has the same value, still it gets initialized again and again and again. So technically, it's a waste of memory. You're just wasting memory of a new allocation every time, even though the value is same. What if we create this object once and this member variable once and just use it across objects? You can do that by just writing static in front of it. If you do that, then you see this becomes sort of italic here, and that's Java's convention to show that this particular variable is a static variable. You can also see the static keyword in front of it. And then whatever value you have specified, this will be initialized only when the class is loaded. Remember, I'm not talking about the object initialization. I'm talking about the loading of the class in the JVM. So the first time the class is loaded, this particular variable will be initialized, and that's it. After that, no matter how many student objects you create, the same college reference will be used again and again, and the college variable will not be initialized again. It will be initialized once, and the same college reference will be used again and again. That's the power of static variables. For example, if I want to access this particular college variable, how do I do that? So let's look at a main class where I have initialized this particular student class with an object named as John. And I've specified the name, the age, and the address, and I'm printing those values. How do I access this static variable? If I say John dot, do I get access to the college variable? Yes, I do have access to it, but does it work? Let's see. You see a yellow line here, and we will come to that yellow line in a while. But let's first see if this works. Yes, it works. I can see that the college name is printed here as XYZ, which I have set. Now let's look at the error or the warning. It says the static field student.college should be accessed in a static way, because the way you are accessing it right now is the instance way of accessing a particular member. This is not a static way of accessing a member. So if you want to access a static member of a class, you should access it with the class name and not the object name. Why? Going back to my original definition that the static variables belong to class. They do not belong to object. And that's why Java will warn you if you are not accessing the static variables via the class, because they are supposed to be accessible via class. It will not give you a compilation error, but if you're working in an enterprise project, this is going to raise a lot of violations and a lot of questions for you as to why you are not accessing it via the class name. So this is the correct way of accessing it, and you will get the same output. Now, no matter how many objects you create of the student class, you can always access the student.college and you can always get the same value of the college name. That's the first use case. Second thing is about static methods. So you will use the static methods in a case where I described about the counting the employee numbers. And let's say if we have the same kind of scenario where you have to count the number of students, because you can use that particular count as, let's say, the roll number of the student. So if you have that kind of requirement, then you need to create a static method because you need to share the state of the object across objects. Remember that. So what you can do simply is create a static method. So let's say I create a normal method and then I just put static in front of it, saying static void student count. And now I want to count the student. So let's create a simple count variable and let's start it with 0. And then I can increment the count variable again and again in the static method, right? But you see, I get an error here. The error is if you go to the balloon, it says cannot make a static reference to a non-static field count. This is one of the properties of the static methods. The moment you make a method as static, then that particular method can only access the static member variables of the class. The static methods will not be able to access the non-static variables. Count is a non-static variable. Count is a normal instance variable. So a normal instance variable for that matter, name or age or address, nothing would be accessible here. If I try to access, let's say I try to access name here. So if I just say sysout and I say name, it will also give me the same kind of error. If I go here, it gives me the exact same error because static method cannot access the non-static member variables of the class. So you have to make this count variable as static as well, and then only this compilation error will be fixed. I can remove this one, and now this method is fine. Now I can increment the count every time that object is created. And that is one of the use case of using the static method, that you can share the state across the different objects. And if you want to fetch this particular variable, then you can simply write a getter for this, saying int count, return count, and then you can return the count. You can see that now an instance method can access the static member. So the reverse is fine. A non-static method can access a static variable, but a static method cannot access a non-static variable. Remember that a static method can not access a non-static variable, but a non-static method can very well access anything, including the static variable. That's second thing. The third concept is of static block. And static block also has a similar usage, that if you have a block of code, it's not just a variable, it's not just a method, but you have a block of logic which you want to execute only once when the class is loaded into the runtime. If that is your requirement, then you can write a static block. And the way you will write it, generally we write it at the beginning of the class. And the way you will write it is as you write static and you put curly braces and you start writing code here as to whatever. You can say initializer, and you can write whatever code you want to write. The only caveat is that in the static block, you will only be able to access only the static member variables of the class. So you will not be able to access these variables. You can only access these two variables. You can very well move these two variables here if you want to. So if I go here, I can paste this and I can drop the static keyword because everything in the static block is automatically static. So I don't need to explicitly call out static variable. And now this code is fine. You get some warning because it's not used anywhere in the class, but that's fine because this is just a simple demo. But the whole point is that you can write the static block and you can write all the initializer code which you want to write here, which you only want to execute once during the whole execution of your program. Just to show you the reason and the way it works, let's try to see if the static block works. And let me comment all the static code which I wrote here. And let's go back to the static demo and let me remove this one as well. So now I just will run this student.java. I will create an object of student.java and I will see if the static block gets executed or not. So let's run this particular class, which is the main class, and I have a main method. I have a student object initialized and I'm printing the name, age, and address. If I run this, you see the first line of code which gets printed in the output console is the static block code, which is what I wrote here. And let me do one more thing just for fun's sake. Let me create more objects of it. Let me just call them 1, 2, 3, and 4. And let's see how many times the initializer code gets printed. You see that the code still gets printed only once, even when I created 5 different objects of the student class. And that's the property of the static block, that it will be executed only once when the program is loaded into the runtime. And that's all. And that's pretty much all what I want to cover in this particular session, where we talked about the different ways the static keyword can be used. We talked about static variables, we talked about static methods, and we talked about static block. In the next session, we'll discuss about the nested classes concept. If you like this video, a thumbs up would be massively appreciated. And please don't forget to subscribe to SimpliCode for more programming related videos. Thank you, and we'll meet again in the next session.